Okay, hello again. I want to talk about when, if you do order a custom crankshaft. Doesn't matter, who you get it from. Well, it does matter who you get it from, but I'll give you the top three. Would be Bryant, Qualler, and Callie's, which this is a Callie's. If you order a custom-made crankshaft, you will not get it in anything under 3 months. I guarantee it's going to be at least 3 months, if not better. I ordered this one from Callie's. I'm going to show it to you here in a second. And I think this is their top of the line. It's a billet Timken crankshaft. This is the best that they make. Callie's does. And I think it's a work of art. I mean, they did a hell of a job on it. And it took 16 weeks. That's what it took to have it made. And they sent it to me once, and I wasn't happy with it. I sent it back to them. They fixed, and it was just a little bit of an issue. They sent it back to me again, and then I checked my clearances. And I'm a pretty picky guy, and the clearances weren't quite where I wanted to be, and they weren't as even as I wanted them to be. Mains, I want to be even. Rods, I want to be even. Sent it back to them again. They sent it back to me again. And the second time they sent it back to me, it's dead nuts. So, and that's just the way these things go. Anytime you're having anything custom made, there's certain tolerances that they go by, and sometimes you need them to maybe polish off the crankshaft a little bit more and give you a little bit more clearance, oil clearance. Anyway, so here's the crankshaft. It's in the block. I said it is, I think it's a work of art. Obviously spins real nice. We talked about that. You see that there's no oil holes drilled into it or anything like that. It's been knived. It's got an REM finish on it. It's got one piece of Mallory in it right here. It's the only thing it's got in it is a chunk of Mallory. They gave me a good deal on it, the crankshaft. But it was 16 weeks. Basically, I waited all summer for it, and I just got it not too long ago. So that's what it looks like. Like I said, I think it's a work of art. A beautiful job. So anyways, I guess basically I'm waiting for my son to get here before we can go any further, because like I said, I was gonna teach him how to build a motor. He's never done anything like this before. He's more into sports, but he's gonna have a go at it, and we'll see what happens. Either way, we're gonna put it together. It's gonna be dead nuts right. Anyways, I'll get back to you when we start putting the rods in the motor, and I'll talk more about things that are coming up. All right, thanks, bro. Well, hello again. If I repeat something that I talked about earlier, it's because I looked at the footage, and there was something that I wanted to talk to you about and I missed. So if I talk about something like, let's say, the engine block, I forgot to tell you about that. When you buy a block, you gotta look at the oil galleries and smooth out the oil galleries and before you send it to the machine shop. I missed that part to tell you guys that. So, if, like I said, if I'm repeating something, it's something that I missed when I checked the footage. I've never done this before. This is all kind of new. Anyways, I guess the next thing we're going to talk about is piston and rings. Also, I'm going to discuss a little bit more on the 347 combination. I want to make it clear on what the stroke's supposed to be, what your connecting rod length is supposed to be, and what your piston pin height is supposed to be. And and remember where I was talking about my pin height is a little weird, and I had them machined. We talked about that earlier, and I'll tell you what I did to resolve it. Okay, let's talk about a 347. We're going to talk about pistons and rings. Anyways, the 347 combination, standard combination, or small block Ford 302. They call it a 302 because, you know, it's 302 cubic inches originally from the factory. Well, you're going to turn it into a 347. So how they get this 347 is it's a 3.400 stroke on the crankshaft. Then your normal connecting rod is 5/400 center to center. Center to center of the connecting rod. And from the center of this to the center of that hole is 5/400 normally. Okay, and then your compression height on your piston is 1 inch 90 thousandths, 1.090. All right, and that's with the 5/400 rod, the 3/400 stroke, your pin height, and that's I'll show you in a second here. I might as well show you the box because it gives you everything on the box. These are the pistons I use. Here's the used connecting rod box. Here's the Molly box. Now you see on the side of the box, gives you all the information you really need. Right? Gives you everything about it. Here's the pin height. 1, and it should have a point there, but it doesn't. But that's what, it's 1.090. All right? You can see that. Should be there. It should be a 1.090. But their point's not there. And it tells you the pin, the 927. Tells you the clips. Spacer rail dimple. And this is the bore. Bore is 4.130. Okay. And then it tells you the rings. To 1.5, which is a metric ring. 1.5, 1.5, and a 3 millimeter. File fit means you gotta file fit them. We'll get into that a little later. So there's the number. See, small block Ford. Here's that pin height. Should be 1 inch 090, but they got 090. 130 stands for the bore. 130. Okay. Oh, anyways, that's the pistons. I remember how I talked about I bought those rods used on eBay, and according to the tech sheet, my pin was from center to center was 5/461, and the pin was a 866 pin. So I wanted to run a 927 pin. I could have had a custom piston made, I could have had it from Molly, make them up for you. $1,500. Yeah, $1,500 in another, I think, 3 months. So these I picked up from $575 for the whole kit. So what I did is I took the 866 pin, my machinist. Sorry, I got a great machinist. He took the 866 pin, we pushed out the bushing. Okay, the bushing was a size, a certain size. At that time, I knew the size, but pushed out the bushing. Then the pin was offset by 61 thousandths, offset. Went this way. And that's all they did is they just took it and they offset that pin and that rod by 61 thousandths, and that's where you come up with 5461. So I pushed the bushing out, and then I wanted to run a bigger pin. I wanted to run a 927 pin to match the pistons, because that's the normal size pin that Molly makes for the pistons. So what we did is we when we machined it, because we had to machine it for the bigger pin, had to machine it for oversized bushing. When he machined it, he machined the offset back down to the big end. All right, you can't even tell that's been machined offset, but actually it was. When you looked at this rod, you could tell that pin was higher than the rod, and so we machined it back down to the rod, because you don't want to machine this part of the connecting rod because it'll make it weak. You don't want to touch this part. So what my machinist did is he came up to the edge of here and machined the rest of it, the bottom part of the rod, oversized. And then he pushed in the bushings with a 4,000 squeeze on the bushings. It's got a 4,000 press on this, and he pushed them in. And then he machined it to 925, and then my other friend honed it the extra 2,000ths to 926. All right, and it's a 927 pin. That leaves me with 1,000ths clearance in there. Is that right? Anyways, there's a 1,000 in between here. I'm gonna go back. I'm not sure. This is a 927 pin. This is honed at 928. Yeah. 928, 927 pin. Gives me 1,000ths clearance. That's right. Sorry about that. Yeah, he honed it to 928. Anyways, the pin fits real nice in here. I'll show you that. So anyways, so now this is currently 5/4, because you can only get half of it out. 5/4 31 thousandths. So 5/4 31, and normally you need a 5/400. So we got an extra 31 thousandths. The piston's going to stick out of the block an extra 31 thousandths. So we need to address that, because from the top of the piston to the top of the cylinder head, when it's together, you need to have at least 50 thousandths clearance in there. So how do we do that? Well, it's pretty simple. You take 31 thousandths off the top of the pistons, and it takes care of that. I can get away with that because I'm running a 60 thousandths gasket. I run 60 thousandths Cometic gasket, and I recommend Cometic. They're expensive, but they're well worth the money. Never have a gasket leak. A lot of the guys that are running nitrous and turbos, everybody runs the same. Everybody runs Cometic. So it's a multi-layered gasket. So anyways, Molly automatically, when they make their pistons, they're always 10 in the hole. So it means they give you 10 thousandths. They're always 10 in the hole to knock off the deck. So what I did is I took 20 thousandths off the top of the pistons. And what I'll do is I'll put the motor together, and I'll check and see how high, see how much the piston sticks out of the block. And if it sticks out of the block, 5 thousandths, I'm not going to worry about it. If it sticks out 10, I might have to do something about it. I might have to cut off another 10. But I don't know, and so you can take the material off the piston, you can't put it back on. So that's where I'm at. So I took 20 off the tops of the pistons. So when I put it all together, when I have 50 thousandths from the top of the piston to the top of the head, I got a 60 thousandths gasket. So that means technically I could put a 10 up. It could be 10 thousandths up and I'd still be safe. And 58 cc chamber head. Anyways, I figured out my compression. I'd be at 11-1. And there's a lot of tools online that can help you figure out what your compression ratio is. I think Summit has a online. They have you put in the numbers and it tells you your compression. And I think Eagle Crankshafts site also has the same kind of software, free. Gosh, yeah. Anyway, so I also will talk about rings. This has this set of pistons got a 1.5 3 millimeter ring on it, and its ring gap is super important. That can make or break a motor, big time. And your eyes run the rings that come with the pistons. Manufacturers, they make these aftermarket rings that you put them with the pistons. But that piston is specifically made for that ring. And buying another ring for that piston might not work out as good as you think. So anyways, piston gap is real critical. So this is the formula that you use. It comes in it, it tells you on there, for your street strip circle, when you're shooting nitrous to it, your ring gap's got to get bigger. If you're running supercharger, your ring gap's got to go bigger or anything like that. And so you take your bore, and they got a formula, and you figure out what your ring gap is according to your bore. Also, ring location, and they don't tell you about that, but the location of the rings, and where your oil ring is, your bottom oil ring, your expander, your ring rail, your top ring, your second ring, they all have to go into a certain location. And it tells you on here when they give you the sheet, the ring's got to go to a certain location according to the front of the block. So look at it. It says right there. Front of engine. So, front of engine. So when I look at the pistons, that's the front of the engine. This is your top ring and second ring are always 180 from each other. Anyways, I spend quite a bit of time putting my rings in a certain location. I say when you start up the motor that the rings move. I don't know. It's a possibility that they move. Maybe they do, maybe they don't. I don't know, as I've never really checked it. All I know is I spend a lot of time getting my rings in the right location. I also spend a lot of time file fitting my rings, and I don't really file fit them with a file. I file fit them with a grinder, and I'll show you more of that. It's a ring grinder. It's a cheap ring grinder. It's by Performo, something like that. Not crazy money. It's like $150. Some of them ring grinders are like $1,500 or something. Well, and again, the ring grinder I bought used on eBay, so I got it pretty cheap. And I take a lot of time and file fit my rings. Now for my rings, I do believe my top ring is 21 thousandths and my second ring is 23 thousandths. So my bore is 4.130. And I don't shoot no nitrous to this car or motor or anything like that. No superchargers, just naturally aspirated. My top ring is 21 thousandths. My second ring is 23 thousandths. And the oil rings, I'm not sure where they end up being, but you know, you just check the oil rings and make sure your oil rings have the proper gap that they're supposed to have. And I'm not sure what the gap is on the oil rings. I know I checked it and it was where it needed to be at, but I couldn't tell you off the top of my head what it was. But rings are critical. Ring location is critical. Gap is critical. Also, I don't put any motor oil on my rings. I use Type F transmission fluid, or I use a Total Seal. Total Seal. It's like a light oil from Total Seal rings. This is specially made for piston rings, but I pretty much use a Type F transmission fluid on the pistons and rings and on the cylinder walls. No oil. Everything else is driven BR30 braking oil. I have I showed you two oil cans. This is both made by Eagle, like from the 40s. They're polished up real nice. So I thought it was, again, I bought it on eBay, real cheap. Didn't look like this when I got it, but so it looks like now. This one's got transmission fluid in it. This one just says Eagle on the top. So I use this one that's just got the training fluid, you know, on my piston rings, cylinder bores, and this one, it's both made by Eagle, but this one's a little different can. It's got it says Eagle, made in the USA, part number. I said it didn't look like this when I bought them, but I took them apart, polished them up. Made them look kind of neat. And this has the braking oil. This has got driven BR30 5W30 braking oil, and I basically use the braking oil on everything except for my pistons, my piston rings, and my cylinder walls. Okay, so I guess I'll get back to you on what we're gonna do next. I'll see you soon.